waste material. Now, the waste material as a supplementary cementitious material. Aluminosilicate, silica, supplementary cementitious material may be divided into the three main groups, depending on their chemical composition, and resulting from their reactivity in hydrating cementing system. These are the pozzolanic material, hydraulic material, and material being inactive or showing only a small reactivity in the cement system. On the right hand side, the chemical hydration process of the ordinary Portland cement and the hydration process of the partial replacement of the cement by the supplementary cementitious material. In hydration process, the cement reacts with the water to form the calcium hydroxide and calcium silicate hydrates. And in the case of cement, supplementary cementitious material react with the water to form the additional calcium silicate hydrate, which is a more compact structure. And the calcium silicate hydrate is the main factor responsible for the strength. Now, the uses of the supplementary cementing material in the concrete are advantageous in many ways. They enhance the concrete strength properties, improve the sulfate attack resistance, chloride ion resistance, and making the concrete easier to pump. And supplementary cementing material also plays a useful role in reducing the water permeability and other fluids, deterioration, expansion, and risk of delayed apprentice. Various supplementary cementing materials like fly ash, ground granulated blast furnace slag, and the silica fume. The specifications of the fly ash, GGBS, and the silica fume is as per the ASTM-C 61894, ASTM-C 98993, ASTM-C 124093 respectively. As per the ASTM-C 61894, the fly ash can be classified into the three types: Class N type, Class F type, and Class C. The Class F has the pozzolanic properties, and Class C has the pozzolanic as well as the cementing properties. In the GGBS, as per the specification C 98993, the GGBS has been classified into the three categories: grade 80, grade 100, and grade 120. These are the physical properties of the supplementary cementing materials and the chemical properties of the supplementary cementing materials. Chemical properties can be determined by the XRF techniques, and we can see that the silica dioxide has a higher percentage in all these three supplementary cementing material, which is responsible for the strength. Now, many researchers have studied the detail about the supplementary cementing materials like fly ash, GGBS, and silica fume, and its role in the concrete industry. Fly ash, as per the Haig et al., have documented that the fly ash is a siliceous or aluminous-siliceous material which can be used as a cement replacement material due to their similar properties of the cement, like physical properties as well as the chemical properties. It also improves the workability, strength in the long-term basis, sulfate attack resistance, and durability of the concrete. Fly ash is formed from the coal burning in the electric power generation, and it has a high pozzolanic activity. In the GGBS, Malhotra et al. Have studied that the GGBS is made up of the material used to make the iron and produced by the blast furnaces at the temperature of approximately 1600 degrees C. Different products like molten slag, molten iron have formed by the combination of coke, limestone, and iron in the furnaces. As per the Kosmatka et al. Have documented that the silica is manufactured from the silicon metal ferrosilicon alloy, which is collected from the oxidized vapor on the top of the electric arc furnaces, and it is being used as a supplementary cementing material for the concrete elements. Silica fume is also known as the condensed silica fumes, microsilica, silica dust, and the volatile silica and micropores. Now, the effect of the supplementary cementing material on the fresh properties of the concrete. The silica metaculin and the silica fume supplementary cementing material are used to reduce the slum and expand the water consumption. Fly ash as well as the GGBS slag reduces the water demand and also enhancing the properties of the fresh concrete at the same time. Now, in a case of the hardened properties and the durability, the compressive strength and durability have been enhanced by introducing the supplementary cementing material in it. During the hydration, the addition of fly ash to concrete can not only minimize the dense packing and water content, but also increases the hydration and pozzolanic reactions, which consequences to deaccelerate the permeability of the concrete. And the calcium hydroxide can develop the voids permeable in nature in the hardened concrete during the hydration process. And supplementary cementing material may also improve the sulfate resistance due to the good pozzolanic activity that enhance the microstructure as well as it is a major factor of the sulfate. These are the overview of the effect of the supplementary cementing material on the various properties of the concrete. Properties like water demand, air void systems, compatibility with the chemical admixture, strength gain, heat generation, shrinkage, permeability, alkali silica reaction, sulfate attack, and the corrosion resistance, as per the Wig et al. 2018. Now, the expanded perlite as a new constructive supplementary cementing material. Expanded perlite is an amorphous, highly porous, granular material of volcanic origin. It has a two main components, aluminum oxide and silicon oxide. Raw perlite ore is mined in the volcanic areas, crushed, screened into a different sizes before being sent to the perlite expansion furnaces. The crushed ore brought to the temperature of 1500 degrees C to 1700 degrees C, where the glass softens and trap the waste molecules turn into the steam, making the small rock particles expand in the same manner that the popcorn expands in an air hopper. These are the applications of the waste expanded perlite on the right hand side. Now, the application of the waste expanded perlite as a new constructive supplementary cementing material. Due to its high activity, ground waste expanded perlite can be used as both the cement substitute as well as a cement additive, depending on the desired property of the final material. In investigation, show that the waste expanded perlite is a material of pozzolanic activity. These are the properties of the expanded perlite, like the particle size range from less than 100 micrometer, and the bulk densities range from 50 to 150 kg per meter cube. And these are the variations of the compressive strength by partially replacing the cement with the expanded perlite. Now, in concrete mix, the supplementary cementing material will be the virtual interest and a practical solution for the sustainable construction, and also construct the greening in respect to the environment. The following conclusion can be derived below. The performance and the strength of the concrete has been enhanced by using the supplementary cementing material. These materials have a positive influence on the concrete performance, like fresh properties, hardened properties, including compressive strength, tensile strength, and also the durability properties. And the environmental, technical, and economic issues caused by the cement production has been neutralized or minimized by using the supplementary cementing material in the cement or concrete. And also the cement usage has minimized to the supplementary cementing material by the introduction of the supplementary cementing material added to the concrete, which may lead to the environmental benefits to lower the emission of CO2. And researcher also focuses on the concept of green economy, which is a significant to the society as well as the environment. Expanded perlites can be utilized as an additive or substitute for the Portland cement due to their high pozzolanic activity. Here is the references. Thank you.
So thank you, Pooja, for giving the first paper presentation on your topic. Any questions from the audience? I have not seen any questions raised in the chat box. Just one question from my side, Pooja, just a query, because please mute yourself because you are having some echo.
Your voice is not visible, not audible, sir. Hello.
Please mute yourself so that you can.
Sir, your voice is not clear.
Am I audible?
Yes, sir. Yes, sir.
Okay. Just one question from my side is that as the silica content in silica fume is over 95%.
Yes, sir.
But it has some problem of agglomeration when we use it in the plastic concrete. So how to get rid of it?
So maybe you use one or more additional waste material like stone dust to increase the properties of the concrete.
No. No, silica fume, when we use it in the concrete while preparing the plastic concrete, then it has a problem that it agglomerate. So how to get rid of that? Have you gone through any research paper based on that?
No, sir.
Okay, thank you.
Okay, Pooja, thank you for the informative presentation. I have one question from my side. Um, am I audible?
Yes,
Sir,
sir.
Yeah. Okay. So can you just highlight the maximum percentage that we can use according to our Indian standard codal provisions of cementitious materials or pozzolanic materials? Pooja, are you there?
yes, sir.
Have you understood the
Sir, your
question?
voice is not clear. Sound reduced, so the voice is
Okay.
not clear.
Can you mute yourself so that I can put the question properly?
समझ में कुछ नहीं आ रहा।
What is the maximum percentage of pozzolanic materials that you can use in concrete according to Indian concrete provisions? Okay.
Abhilash sir, you may write it in the chat box if required.
Please read in the chat box and answer, Pooja. Okay, thank you. Saurav sir, if there are any questions from the audience, or we can move to the second
No, there
presentation.
is no question from the audience.
So we can move.
Yes. Pooja, you
We
may
can,
stop the presentation. आप पहले प्रेजेंटेशन बंद करिए इससे गूगल मीट से और अपने आप को म्यूट करिए पहले okay now next participant is Nancy Soni you please upload your presentation and start presenting. Nancy Soni, paper ID 13. Is Nancy present? Okay. Next is Kanchi Durai S, paper ID.
Yes, sir.
You please upload your presentation.
Yeah, I got to start. Yeah.
Thank you.
Thank you. Yeah, sir, is my screen is visible?
Yes, it's visible. You please make it. Okay.
Yeah. So, good afternoon, everyone. I am Kanchi Durai from Sastra University. My topic is a fracture and impact study on steel fiber and wire mesh embedded concrete that I just produced. And so the concrete floor slab is a structural element consisting of a horizontal surface. It is generally classified as a ground bearing or suspended. The slab directly resting on the ground is called ground bearing or else suspended. A structure subjected to a various type of load in its lifetimes, and due to that various type of load, it started to get creep, impact, and a lot of shrinkage effect. Its main causes. So that that impact loading it plays very vital role for structural slabs. To strengthening the slab is very important by adding some strengthening material and wire meshes that I have used in this project. Okay, my objective is to investigate the structural performance using single and double layer mesh embedment in concrete and addition of steel fibers to evaluate the compressive strength and fracture toughness and impact resistance of the mesh embedded and steel fiber concrete versus control specimen. So to study the failure pattern of concrete units and compare the control specimen failure pattern, to examine the mesh embedded material fracture response, that is a fracture toughness, the opening mode, that is a mode 1 fracture, there is a opening mode test I have identified and identified the maximum stress intensity factor. So by ENDP, edge notched disc bend specimen. So to investigate the material resistance through the crash propagation and its nature. Okay. So from the past 10 years of research work, the 21 literature paper was referred to this research work from 2011 to 21. The literature studies were related to the different embedment in the concrete construction and a few novel technique. And here for a research work, the most related literature were presented. The first one, the Go et al. He has investigated. He has used the embedment with the non-embedment. With that, he has done the investigation. With the impact load, it can affect the entire system of the specific part. The cracking is a major problem faced by all airport and runways payment. If the payment is not good, it will affect the engine repairing, and the engine is not too easy, and the cost is very high. Hence, the impact energy plays a vital role in the runway payments. Next. So next to that, Kaya et al. He has used that embedment steel fiber and mineral admixture. He has found that impact resistance, good impacts resistant, and its sudden failure what is prevented when you are using the steel fiber and mineral admixture. Similarly, Sherke et al. He has used the rubber and then rubber materials and welded wire mesh as used for a payment, and he found that the steel fiber improved the impact strength, and by providing the meshes can avoid the shrinkage cracks in the slab. Similarly, the Engpan et al. He has used a glass fiber reinforced polymer, the GFRP, and engineering cementitious composites materials that he has used, and found its fiber could resist the impact without failure. The minor micro cracks were noticed after the experimentations without getting the major cracks. So Elmira et al. Is used the stain hardening cementitious composites. It's an addition of cementing material. The RC slab get either the top or bottom pieces achieve the promising results. The Mastani et al. Is used functionally graded reinforced. So the grading, the coarse aggregate grade is made by a functionally graded reinforcement, and the steel fibers as additionally used. The RC slab with the steel fiber and increased numbers of blows and show the excellent performance. Similarly, the Elavarasi et al. He has used the slurry infiltrated concrete with the fiber, slurry infiltrated fiber concrete she has used, and then the crack resistance is found is higher. Similarly, the Vimal has used the fiber concrete, a different fiber has used. The fiber concrete, its slab specimen is again the impact behavior. It is used to 243 kg free falling drop weight hammers, and it has found the good promising strength. And Hassan et al. Is used the wire mesh reinforced. So the wire mesh reinforcement is capability is to resist the forces from the many direction. Hence, it is increasing the volume fraction of the wire mesh. It is increasing the puncturing of specimen. Similarly, the Ahmed et al. Has used the welded wire mesh in the pavement. He has found the good strength and reliable strength. And Rohala et al. Is used the mono hybrid fibers. The tested 3-point bending test employed with a notched specimen, and he has found the good strength in the material. Similarly, CFRP material is plays the vital role. Fiber reinforced polymer steels and synthetic fibers, additives, and steel polymeric hybrid fibers are achieving good strength against impact, fracture, and compressive strength of the concretes. And here my need for my present study is from the present literature. It is clear to understand that the different forms of strengthening technique was adopted by a FRP and steel materials. The worldwide research were carried out the research strengthening technique using the different materials by using the GFRB, FRP, BFR, CM, and CFRB twisted bars in polymerics and polypropylene bands and engineering cementitious material, etc. The fiber and welded wire mesh addition together were tried to cast the concrete specimen in my study, and the study aims to given the simple solution and for a concrete improvement. And furthermore, the mesh embedment and for steel fiber addition method is a simple and reasonable and straightforward procedure for the field execution. Moreover, it resists the impact and fracture than the normal concrete. So here it's on mesh embedment technique that the welded wire mesh could be added with along with the steel bars, 5 mm steel bars. Actually, these kind of disc specimen is used to identify after embedment the fracture toughness. Okay, the easy workmanship meshes are locally available. The mesh and steel fiber embedment may have well anchoring and force may transmit equally. The easy placement of mesh at the time of concrete, the performance against the structural effect can be better since the mesh arrangement will resist the force from the any direction. Here the spacing of the mesh is very small, hence we have used 12 mm aggregates. Okay. By scope is to the strength of the concrete were studied, the structural parameter like compressive impact, fracture toughness to be evaluated. The structural effect was monitored, reduction in the brittleness were identified, and the increase of strength was measured. This research work of following experimental work was done, and the compressive strength of the concrete 21, and the impact test specimen is 21, and the fractural test ENDB specimen is 4, and the concrete slab is 9, casted and then tested for our experimentation. Here the materials which I have used, the ordinary Portland cement and fine aggregate, which has the grade is relatively this 1 mm and 1 to 2 mm, like that it is the percentage of passing. And the coarse aggregate is having the more than 10 mm, exactly the average 10 mm aggregate size were used, and it is produced that impact value is 20.8%. The steel fiber is 0.5 mm steel fiber. It is having the 25 to 35 mm length, and the ductile material has taken the 250 Newton per mm squared as a yield strength for the steel fibers. And the mesh reinforcement, these are all the typical locally available material, which is the welded wire mesh. It is a 2.5 mm thickness, and it's having the spacing 150 mm with the HYSD. So I have used the HYSD bars as well as 8 mm bars as well as the welded wire mesh. And the experimental study is for a first 21 numbers of 100 mm cubes. M25 is casted as a 1:1:3. It's the trial mix is 390 and 1170 as a proportion of 1:1:3 was maintained to make a concrete, and test performance is made as per the guidelines given in the Indian standard. And the compressive strength of the concrete, the addition of steel fiber is made a design is 0.5 and 0.75 and 1% with respect to the cement weight, and the consideration of first set also the welded wire mesh and the steel fibers are added together for another set. The compressive strength test observed that the addition of the steel fiber could be considerably increase the strength and performance. The result shows the welded wire mesh addition compressive strength was of 17% higher than the control specimen. The fiber and mesh reinforced concrete that is 27. It's taking more than it's elevated. The strength is 27 compressive strength and the control specimen. And here the results of the compressive strength, when the first one is a control specimen, is and second one welded wire mesh addition. It's if you are seeing the M25 concrete, it's averagely it's 28 average 28 days. Strength is we are achieved at 28.65 Newton per mm squared. Similarly, when we are adding the welded wire mesh, 33.7 Newton per mm squared we have added. Similarly, steel fiber with 0.5% is 29, and steel fiber when increasing 0.75 is 30, and steel fiber when addition is 1% is 32 megapascal we are seeing. And similarly, the welded wire mesh and steel fiber 1%, which is adding in the fiber and mesh reinforced concrete specimen is achieved more percentage, that's 36.08. We have not gone beyond 1%, hence weight of the material is getting more. Hence, we have restricted up to 1% of steel fiber addition. Similarly, the experimental study for the impact of concrete disc when we are dropping the weight, it was tested, it is getting numbers of below is higher when we are adding the steel fiber. The steel fiber actually resisting the more impact strength. It's giving the more impact strength considering the normal concrete. And the stick specimen is 150 mm by 50 mm thickness, which we have used. The impact strength, which is specified by a number of blows when we are dropping from the 1.2 meter height of 2.7 kg weight of steel ball. And the control specimen is having within 8 numbers of blow, it started to failure. And welded wire mesh embedment is resisting up to 16 numbers of blow. And then steel fiber 0.5, 0.75 and 1% is gradually it's increasing. And similarly, the fiber and mesh reinforced concrete, it's giving the more resisting more impact strength. The experimental study of fracture when I have identified the fracture toughness.
Sorry, Kanchidura, your time is over. Please conclude.
Yeah. So similarly, this is an experimental study for fracture stress. Here we have identified the fracture toughness of the specimen. In the specimen, the fracture toughness is when we are adding the wire mesh, it's getting increased. So immediately it will not break. It is giving more resistance against the fracture when we are making a notch of crack on the material. Similarly, here the slab is casted for a 600 by 600 by 65 mm thickness, and we have embedded the steel welded wire mesh and then steel fibers together, and it's giving the higher resistance. The blow difference you see 1434 numbers of blow when we are using the fiber and mesh reinforced. So, but it's giving the greater resistance, and we are considering 79 blows to 1434 blows. Okay, it's almost 10 times, almost 8 to 10 times is higher comparing to the normal concrete. So the energy absorption capacity by kilojoules we have measured, and then the energy absorption capacity is mass, gravity, and height, and numbers of blows. With that, we have identified that here 24 kilojoule. We have identified the more energy absorption capacity in the fiber and mesh reinforced concrete. Similarly, it's a graph, the same graph. And similarly, the crack resistance we have identified, its crack resistance ratio is 13% comparing to the 13 times it's comparing to the normal concrete. And it's a sample calculation for the crack resistance. And similarly, the failure pattern
please conclude. We are having what time? Please
it's a failure pattern, and this one it's a final reduction. And the final I would like to conclude the energy absorption capacity is 70% is higher, and the fiber reinforced concrete when we are adding the addition of 1% is showing the better noticeable increment. Similarly, the fiber mesh and reinforced concrete is having the in failure, it's controlled. And similarly, the crack resistance is fiber is increased at 21%. Similarly, the fiber reinforced slab is increased 11% in the control specimen. Obviously, that the crack resistance 14% is higher, and the maximum crash is giving the external resistance in the materials. So these are all my reference that I am concluding. Thank you.
So thank you very much, Kanchidurai. Any questions from the audience? I have not received any question in the chat box. One question from my side that
yes.
How the volume fraction of the steel fiber you have taken in your research?
Yeah, I have actually weight usually I considered in for first case is considering the cement weight which we are using for a casting. Based on that, I have used steel fibers percentage.
So that's percentage you have taken as per the percentage of cement.
Yes.
But in research, the volume fraction is more important, and aspect ratio. What was the aspect ratio of your steel fiber?
Steel fiber, once again, it's a point. Actually, it's a 25 mm length. So almost it's coming 1 to 2. It will come.
Okay.
Yeah.
And anything you have done for the durability
No, not at Solan,
criteria?
sir. In the future, I have planned to consider the durability test.
So while casting the concrete with steel fibers, have you interrupted with some workability issues?
Yeah, I got the reduction in workability. It's 10 mm or lesser than that. I have got that I have. Yeah.
Any method you have taken or any
No,
procedure you have adopted to overcome that workability?
no. Actually, I have casted when I'm reducing in the workability. I have casted as it is to consider the test in the worst. Actually, that criteria I have taken, but I have not considered this. It's not much. It's not collapse actually.
Okay.
It's a shear failure only. So I have directly used for the casting the concrete.
Okay. It's okay from my side. Abhilash sir, anyone if you wish
Yes,
to
sir.
ask?
Yes, sir. I have one question. Professor, how did you account the stress concentrations in your sample? Have you taken any strain gauge or stress strain history of your
Actually,
sample?
yes, sir. The fracture from the fracture studies, I have used the notched specimen. So
Uh,
when we are giving the opening mode, it is started to failure here. So the stress already we have started give the cracks, the failure point here. So when you are providing the load, so that here inside the mesh were embedded inside at the top layer. So
hmm.
here 1 centimeter notch were provided as per that Irwin formula. When you are going,
Okay.
so
Okay.
based on that stress intensity factor was considered.
Okay. One more question. You have not used coarse aggregates in your concrete, right?
Post aggregate 12 mm post aggregate that I have used.
Okay. So have you faced any settlement of fibers in your samples?
No, I have mixed hand mixed. It is not. I have not spaced the surface because I
No,
have
no,
ran.
that is fine. But after vibration, after vibrating of concrete during
Yeah,
casting,
yeah,
have you experienced any settlement of fibers at the lower end?
yeah. But I have not used the
Have
vibration
you
at
observed the sample after testing?
yeah, I could
Have you
understand.
observed this? Yeah.
Yeah, but I have not faced this kind of issues because I have used manual method to make the concrete separately, and then I have taken that sample and filled the concrete cube. So when we are
Okay.
going for a larger, it may be the issues may be raised when we are using the vibration. That I could understand, but manually not get that much segregation.
Okay.
Yeah.
Okay. Thank you. Thank you, Prof. Thank you.
Thank you, sir. Thank you.
So thank you, Professor Kanchidurai. You
Yes,
may
sir.
stop the presentation.
Thank you.
And next is Achal Agrawal. You please upload your presentation and start presenting.
Hello.
Yes, hello.
Yes, am I audible?
Yeah, you are audible.
Okay. Okay. So shall I start, sir?
You please upload your presentation and start presenting.
Is my screen visible, sir?
No, your screen is not visible yet.
Okay.
There is an option of present now in the tab. Just click on that and it will be directed.
Wait a minute. Okay. Is it visible now?
Yes, it's visible.
Okay. So very good afternoon. I'm not present here. I'm Achal Agrawal, and the presentation of the topic of my presentation is review on the durability parameters of self-compacting concrete. So I'm a research scholar at ICCME2021, Mukesh Patel School of Technology Management and Engineering. Content of my presentation is introduction, advantages of SEC literature review, durability, conclusion, and references. So first of all, the term self-compacting concrete. Some of you might be knowing about self-compacting concrete, some of you might not. So it is a one kind of special concrete. Why I'm saying is it's special because it is different from conventional concrete. So it is a concrete, it's special concrete which can be placed and consolidated without any vibration efforts from outside. Okay, so Now, if someone may ask why, how a concrete can be qualified as SCC. So, as in the previous presentation, Abhilash sir may have asked about to the sir, Kantipuram sir, that have you taken any measurement about the slump or the workability? So, one thing which is very sure about this SCC is its workability is one of the measure which when a concrete can be qualified as a SCC. So, there are 4 tests. So first of all, sir, we do in Indian standard, we do not have any guidelines of any Indian standard codes to measure the self-compacting concrete or to measure the workability of self-compacting concrete. So based on the European guidelines, there are number of methods, there are number of tests which are available to consider a concrete as self-compacting concrete. Out of those, 4 are listed here. One is flow table, second V funnel, J-ring, and L box. So there are these 4 tests which we perform in the fresh state of concrete, and if the first is flow table. So in this we use that cone, and if the diameter of spread is 600 to 800 mm, then it is called as self-compacting. Second, if there is a V funnel, if we allow the free flow of concrete from the V funnel, if this funnel is emptied in 6 to 12 seconds, then it is self-compacting. There is another J-ring and L box. These are some of the tests which we perform in the fresh state of concrete. And if the concrete, the values range in between these values, then we can call our conventional concrete as a special concrete, which can be termed as self-compacting concrete. So one thing, as I already said, it is a special concrete which can be placed and consolidated under its own weight without need of any external vibration. So there are some advantages of these. It eliminates the need of vibration first. Second, it decreases the construction time, labor cost, noise pollution, and permeability. It improves the filling capacity of congested structure members. Like as we have seen, there are many structures here which are heavily reinforced. So in those structures, the placement of concrete, like the application of vibration, which we have needle vibrator or other kind of vibrators, so concrete may not be placed it may not be consolidated completely. So it is one kind of concrete which can be used in heavy reinforced structures first. Second, it can also be used in those structures which are severely affected to environment, which are imposed to severe environmental conditions. So because this is a special concrete, so what we do in the designing of this concrete, we reduce the percentage of coarse aggregate. In conventional concrete, what we use, generally we use 35 to 40% of coarse aggregate, right? But in this kind of concrete, we reduce the percentage or volume percentage of coarse aggregate by some fillers. It may be cementitious material, it may be fine aggregates, right? So that the volume of fines is increased. If there is a concrete where the volume of fines is more than the volume of coarse, obviously it will improve its permeability, it will improve its density, right, sir? So this is one kind of concrete which improve the durability of concrete. So my paper, in this presentation, I have focused only on the durability parameters of self-compacting concrete. In this paper, what I have reviewed, we have reviewed 23 papers, 23 research papers, which were based on the durability parameters of self-compacting concrete only, right? So out of those 23 papers, what I have reviewed some things which you can see here. The frequency of mineral admixtures used a partial replacement of cement. See what now? As I have said, we need to increase the volume of fines. Fines means we can increase the cement content, we can increase the fine aggregates, right, sir? So, but if there's one thing is for sure, that we can replace the cement partially by some of the cementitious materials, by some of the other fillers, so that we can get the economical concrete first, as well as we can improve the durability, so that we can improve the permeability. Okay, so in the papers which we have reviewed, so this is the data when they have replaced the cement partially in this much of percentage. So we can see from this pie chart, in the maximum papers, they have replaced cement using fly ash and limestone fillers, and rest is metakaolin, silica fumes, rice ash, and all we can see here. Is it clear now? So moving further, frequency of fine aggregates. So out of those papers, only for natural fine aggregates, like approximately 70% researchers have used natural coarse aggregate, which are natural fine coarse aggregates, and some of them have like mixed natural with recycled aggregates. with bottom mesh, with copper slag and marble based. So this is the percentage we can see here. Next is percentage of frequency of coarse aggregates. So approximately 70% researchers have used natural coarse aggregates only, and 26% have used natural aggregates with recycled aggregates, and only 4% have used artificial aggregates along with natural aggregates. Last but not the least, we have they have used superplasticizer. As I said, a concrete which needs to be a self-compacting concrete, it has to be some characteristics in its fresh state so that it can qualify for self-compacting concrete. So to improve the workability, what we need, we can, as we have I have already said, we can improve the percentage of fines, we can increase the water cement ratio, but it will lead to the decrement of the strength. So instead of increasing the water cement ratio, we can use the superplasticizer. So superplasticizer can reduce the water content and we can achieve the required workability. So in the research, what we have reviewed, they have used some superplasticizer. So these are the percentage of researchers use different kind of superplasticizer available at their end. So we can see here, these are the different superplasticizer which they have used in their research. Okay, so now, as I already told you, we have only considered the durability parameters of concrete. As we know what is durability, it is the ability of concrete to resist weathering action, in simple words. So there are many parameters. There can be n number of parameters to consider to measure the durability of a concrete. But in this review, what we have considered only 4 parameters. One is sulfate attack, chloride penetration, water penetration of permeability, and carbonation depth. So sulfate attack, what is the effect of sulfate attack? It combines with CSH and it destroys. In short, what we measure in the sulfate attack test, sulfate attacks the concrete and it reduces the weight of concrete. It decays the concrete. So it is the one of the measure which is the which gives you the reduction in weight of concrete at number of cycles. So out of those papers, out of those researchers, 4 of them have studied about the sulfate attack. So this is the on the scale which we can see is 0.5, 1.5 is the percentage weight lost. Okay, so there are 4 researchers. Some of them have used only 1, 2 or 3 mixes. Some of them use 7 to 8. So what I have done, I have used this kind of statistical presentation tool so that we can see the variation in the different kind of mixes. If you want to go into detail, then you can please refer the research review paper which I have submitted to the conference. Okay, so this is the sulfate attack test results. Now, second is effect of chloride attack. So chloride attack, what chloride attack is one of the measurement of workability of durability of concrete. As we've seen, it is RTPC test, RCPT test, rapid chloride penetration test, where we pass the charges from from the concrete cylinder, and it gives you the value in coulombs, like how much coulombs have passed in 6 hours. So if the coulombs passed is less than 1000, then chloride penetration is very low. Okay, so in concrete is very good, but if it is more than 4000, then it is very severe. So depending upon the researchers what they have done, so this is the different researchers what they have done in their research work, and I have showed it here in this kind of chart. So 0 is the 0 coulombs and 4500 is the 4500 coulombs passed in 6 hours. Okay, so this is the presentation in this format. There are again some of the researchers use 2 or 3 mixes and some use 7 mixes. So this is the explanation presentation. Okay, so moving forward, we have effect of water penetration. Okay, so concrete foundations are porous. We can say concrete can be porous. So if water is penetrated, water can seep into the concrete, it will ultimately break down the concrete. So it is one of the measurement which gives us durability parameter, durability properties of concrete. So again, this is the presentation. We have 1, 2, 3, 4, 5, 6 researchers which use which have performed this kind of test, which is water penetration permeability. So in this 0, 10, 20, 30, 40, 50 is the mm. This is the mm of the depth of water penetration, like up to what depth water is penetrated in the test, and this we can see here. Okay, so next is last, which is the carbonation. So carbonation is the reaction of carbon dioxide in the environment with the calcium hydroxide in the cement paste. What it does, it ultimately lowers the pH, and as the pH is lowered, the So at this value, protective oxide layer surrounding the reinforcement steel breaks down and corrosion becomes possible. So the increased volume of rust exerts pressure on the or thrust on the cover of concrete, and it results in the cracking and spalling of the cover and the concrete. So this is one of the measurement where it is shown in this kind of chart. Again, there are 1, 2, 3, 4, 7, 8 researchers which have performed this carbonation depth test, and maximum number of tests was 6. Okay, sir. So the conclusion after all the review work, what we can conclude here that even a small dosage of mineral admixture shows drastic improvement in the durability. See, obviously, self-compacting concrete is itself a concrete which can improve the workability, which can improve the durability. So, if you are using the mineral admixtures, it will improve the durability first thing. Okay, addition of 30% of total binding materials as powdered mineral admixture makes the specimen less vulnerable to chemical attack. Then, addition of 10% metakaolin along with 20% fly ash or limestone powder to the mix increases the resistance of mix against carbonation up to 17%. Chloride penetration up to 60% and water penetration up to 10%. So this is one kind of inferences from few papers that if we are adding the metakaolin with fly ash, then we can improve the durability parameters of the concrete. Also, by replacing 30% of cement by fly ash in the mix, very low range of Coulomb charge were passed. Like in the RCPT test, which were measuring the Coulombs pass in the from the concrete. So if we are replacing the cement with fly ash up to 30%, like we are increasing, so we can get the less number of Coulombs, so we can ultimately get the more durable concrete. Addition of steel fibers has also helped to reduce the resistance. Concrete reduced resistance against the carbonation attack by up to 20%, and 50% was found to the optimum value of rice husk ash, and like 15% was the optimum value of rice husk ash. If we are including the like adding the 50% of rice husk ash in the concrete, then it will give you optimum value. But if we are increasing the value, if we are decreasing this value, then resistance can be like reduced. So ultimately, what conclusion I'll conclude this presentation by saying, if we are using self-compacting concrete, it will ultimately give you better durability as compared to conventional concrete. But if we are using different admixtures with different fillers, and we are improving the durability, so we can improve the durability of concrete up to certain percentage. Also, along using the steel fibers can also help in improving the durability parameters of the self-compacting concrete. So that is from my side. These are the references which we have used, and thank you.
Okay, thank you, Achal, for delivering your presentation.
Thank you, sir. Thank you so much.
Any questions one may ask in the chat box, we will take few of them. Not now. One question from my side is that how you have taken care of, you are claiming that using the SCC cement will increase the durability aspect, because while using the low water cement ratio, the plastic shrinkage of the concrete will definitely become high, or the plastic shrinkage cracks will occur. So how how in SSC this is overcome? That's the first question from my side.
Okay, sir. So first of all, I didn't consider this plastic shrinkage right now, but for what I have done right now, actually I'm working on this topic as well. So cement, obviously, if you are decreasing the water cement ratio, plastic shrinkage will occur, but we are not decreasing up to 0.35 or 0.35 water cement ratio. So we are maintaining the water cement ratio which is required, up to 0.38 is required, but we are considering from 3.5 to 0.55, and we are to improve the workability, we are using the superplasticizer. And also, sir, in the previous research, like what we have reviewed in last 2 years or whatever, so what we have seen, if we are using the superplasticizer, it also enhances the durability parameters, or we can say mechanical properties of concrete, right, sir? What I'm focusing right now, if I'm saying if I'm claiming it is the self-compacting concrete giving you better durability parameters, which we have reviewed from the papers. Also, this is one concept, sir. If we are reducing the porosity of concrete, we are reducing the permeability of concrete. So ultimately, it will reduce the way or the passage for chloride ions, sulfate ions, or water particles. So ultimately, it will increase durability. Right. This is what I feel. And also in the research, in the papers, what we have reviewed, we have seen these.
Okay, okay. Thank you. So, any question from Abhilash, sir?
Yes, sir. I have one question.
Please, sir.
Yeah, first of all, there is one suggestion that
Yes, sir.
whenever you are quoting any super plasticizers or any water reducing admixtures, do
Yes,
not
sir.
write the brand names that you have
Yes,
used
sir. Yes, sir.
Solan, Viscofate.
Yes,
Always
sir.
write the basic base, that is whether it is
Actually, sir,
PP based or
these are
P.
polycarboxylic ether based super plasticizer.
So
Everything.
polycarboxylate ether with solid content percentage is enough.
Yes, sir.
So
Yes, sir. Okay, sir.
you do not have to write any brand name
Brand name.
because you're
Yes,
not.
sir. Sure, sir. Sure, sir. Sure, sir.
Secondly,
I'll keep it on. I'll keep
secondly,
it on.
what is the role of VMAs in self-compacting concrete?
VMA, that is viscosity
Because you
modifier.
haven't described any VMAs in your presentation,
Yes, sir. Yes,
although
sir.
it's a review presentation, so I wanted to ask, what is the role of VMAs in self-compacting concrete?
So the thing is, if you're using VMS, we may like avoid the self superplasticizer. So this is the viscosity modifiers, right, sir? The role of viscosity modifier agents as well as superplasticizer somehow relatable, right, sir? So in these papers which we have reviewed, we didn't see the like considerable amount of VMAs, so we didn't bother to include them. Obviously, there were some papers where they have used VMAs, but like they were very less in the percentage, so we avoid them. And okay, obviously in our research work we'll definitely consider them, and I'll keep in mind in the upcoming research work I'll definitely consider VMS as well.
Okay, thank you, Achal.
Thank you
Thanks.
so much, sir. Thank you so
Okay,
much.
thank you, Achal and Avilash, sir. So, for this slot, that is from 12 to 1 p.m., we have covered up the few papers, and from 2 p.m., that is the from post lunch, we will start. So, it's my request that please join this Google Meet classroom let 10 minutes before, so that it can be started right from 2 p.m. And we have almost 11 papers in that, so we will cover it up. So thank you very much, and let us join at 1:50.
Okay, sir. Thank you, sir.